Hi, I'm Tom English, and this lesson is about parallel lines. And if you think about the common definition of parallel lines, they're two lines that don't meet. But I think it's important to recognize one of the things is they have to be in a plane. We can have lines that don't meet, but they're what they call skew lines. And the easiest way to demonstrate that, I think, is if you look at a rectangular solid that's six-sided, more commonly known as a box. If we look at the ends, we could say that the top and bottom line of this end are parallel. They're in the same plane, the same way with the vertical lines on the side. Those are parallel lines, and they happen to be in the same plane. But if we look at let's say the bottom of the box, this angle, or this side here, does not meet or is not parallel to this side because they intersect if we're looking at this plane, but they are intersecting lines because they're in the same plane, but they're not parallel. But if we took this line with the top line on this side, we can see that they're going in different directions and are in different planes, and therefore would be known as skew lines. They never meet, but they're not in the same plane. Another example would be, could we find some way to say, if we take this bottom line of the front panel here and match it, let's say we put a line in the middle here, is there any way that those could be considered parallel lines? Actually, I mean, this bottom line here is on the front panel, this line is on the top panel. It looks like they would never be in the same plane, but if you turn the box and you think about a plane that contains those two lines slicing through it, it's another example where two lines will actually form a plane in and of themselves, and those two lines would, in this case, happen to be considered parallel. When we have two parallel lines and we cross them with a third line, this is the type of problem you're going to be faced with in geometry quite a bit. It forms, the third line is called the transversal, and the transversal cutting through two lines, it doesn't have to be parallel, will form 8 distinct angles. And it's important that you know the relationship of these angles, because if you can prove what we call the corresponding angles are equal to each other, then you can say that the lines definitely are parallel. Let's look at these 8 angles, and they each have a name, and their relationship with other angles is important. We start by naming up in the upper left-hand corner here, 1, 2, 3, 4, 5, 6, 7, and 8. You'll notice I also had the area between the two lines is called the interior, and the area on the outside, below and above, is called the exterior. So when we talk about interior angles, obviously looking at this we can see that angle 3, angle 4, angle 5, and angle 6 are the interior angles. What would be the exterior angles? Exterior would be angle 1, angle 2, angle 7, and angle 8. Those are exterior. Now, we also talk about alternate, and when we say alternate, we're talking about the alternate sides of the transversal. In other words, 1 is on the alternate side of 2. 4 is on the alternate side of not only 1, 3, 5, and 7. So you make sure that you understand which side of the transversal the angles are on. And when we talk about alternate interior, the alternate interior pair in this case would be 3 and 6. Those would be a pair, and we'll find out later why we consider them a pair. And angles 4 and 5, angle 5. Those would be considered a pair of alternate interior angles. They're on opposite sides of the transversal and they're interior. Exterior, alternate exterior angles. Well, the team to 1 is 8, so angle 1 and angle 8 would be considered alternate exterior angles. And then angle 2 and angle 7 would be the alternate exterior angles. Corresponding angles, those are angles that are in the same relative position with the transversal. For instance, if we look at angle 1, you can look at that and say, well, with its parallel line in the transversal, it's in the upper left corner. Well, what other one looks like that with the second parallel line? Of course, it would be 5. So angle 1 and angle 5 would be considered corresponding angles. And we'll see why we want to make that distinction in a moment. Corresponding angle to 2 would be 6. So angle 2 and angle 6 would be a pair of corresponding angles. What corresponds to 3? Well, it's in the lower left-hand side, corresponding with 7. So angles 3 and angle 7 would be corresponding, as would angles 4 and angle 8. Okay? And lastly, we have adjacent angles. Lastly, we also have vertical. Adjacent, we know if we have two angles together, the important thing here is that if they form a straight line, then those angles are considered what? Supplementary angles. They form a 180-degree line. So angle 1 is adjacent to angle 2, and angle 1 is also adjacent to angle 3. And I hope you see from that, if I know 1, then I can easily determine 2 and 3, can't I? All right, and the same way for the lower portion. And how about vertical angles? We knew vertical angles. 1 and 4 are vertical. What do we know about vertical angles? Vertical angles are equal, aren't they? What this comes down to is that if we know one angle, we can figure the other 7 out very easily, if the lines are parallel. Okay? If the lines are parallel, then what we can say is that the corresponding angles are going to be equal. The alternate interior angles are going to be equal. The alternate exterior angles are going to be equal. So once we know one angle, we can figure all the others. Let's take an example. Let's start with 1. It looks like it's a little greater than 90 degrees. So I'm going to say angle 1 is equal to 100 degrees. Now if angle 1 is equal to 100, what would angle 2 be? Well, they're adjacent, aren't they? And they form a straight line, so they're supplementary. Supplementary means they add up to 180 degrees. So angle 2 is going to be 80 degrees. Well, if 2 is equal to 80, what is 3? 2 and 3 are vertical angles, and 1 and 3 are supplementary. So either way, we can figure out that 3 must also be 80 degrees. How about angle 4? Angle 4 is vertical to 1, and it's supplementary to 2. It's going to be 100 degrees, isn't it? And quickly you're going to find that 1 and 5 are corresponding, so if 1 is equal to 100, then 5 is equal to 100. 6 is corresponding to 2. 2 is 80, it is 80. Angle 7, vertical to 6, it's also equal to 80. And finally, angle 8, it's corresponding to angle 4. Angle 4 is 100 degrees. Now, the key here is, again, if you know one angle, you can calculate all the others. The other thing is to recognize that, look, the angles, there are only two values to be concerned with. An angle is either going to be equal, two angles rather, are either going to be equal or they're going to be supplementary, aren't they? So you need to look at them and say, oh, if I know 6 and I'm asked for 5, I can say, oh, they're supplementary, they're next to each other. So if 6 is 80 degrees, then 5 must be 100. If they are vertical to each other, they're equal to each other. So recognize this. Once you know one, you know the others, and there's only two values. They're either equal to each other or they're supplementary to each other. Thank you.